Hi, my name is Shayda Haval.
My name is Diya and we're from Ishik Nilufer Schools.
And we're 8th graders. Today our topic is how points measure area, the Pick's theorem. Now today our topic is about this on how the Pick's theorem can help you find the area of any shape just by counting interior and boundary points very easily. My friend here is going to demonstrate the proof of it very easily. Go.
So suppose that there are n triangles here. In this hexagon shape there are 6 triangles. So a whole area of this triangle is 180 degrees. So n times 180 equals to I means interior points, B means boundary points. Times 360 because we cannot do another triangle here. Plus B minus 2 times 180. Now we divide all by 360 because there's a full rotation here and we need to get 1/2, which full area of a right triangle is 1 times 1/2 equals 1/2. So when we do that we get n times 1/2 equals to B/2 minus 2/2, which is 1 plus interior points. So when we do that, n times 1/2 is the total area. So area equals interior points plus boundary points over 2 minus 1.
Now we're going to demonstrate how to do this on an actual shape. First, we're going to start by counting the interior points. Go ahead.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
That's 17 interior points. Plus, now we're going to do the boundary points. For starting by boundary, go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 32.
33 over 2.
Minus 1.
Now first we do boundary points. 32 over 2 is 16. 16 plus 17 equals to 33. And then 33 minus 1 is 32. That's how you can find the area of a complicated shape by this, just by counting with your hands. You can do this very easily instead of doing a big complicated geometry formula. Thank you so much.
Thank you.